Let's go to the second part of the question. So it's the same thing what we have done before. They have changed the sample mean this time. So the question B says, if the sample mean were 98, what sample size is needed to be significant for a two-tail test with alpha equal to 0.05? So again, it's a two-tail test and again the same alpha level. So we don't have to calculate the critical value again, as we have already found the critical value here, which is 1.96. We can move forward with the calculation. M is equal to 98 this time. So let's start that one now. So critical value is same as before. So this is the boundary for the rejection region, plus or minus 1.96. And then this time M is equal to 98 instead of 96. Now it's 98. So only M has changed. You have to do the same thing. So the first thing we are doing, we are going to make the test statistic equal to the critical value. So test statistic, that is C, is M minus mu divided by sigma M. So this C is going to be equal to the critical value. So 1.96. You can use either positive or negative. M is equal to 98 minus mu is equal to 100. Divide by sigma M. As this side is negative, I'm making this, I already made this side negative, or we can just go with this and I'll show it doesn't matter. So I'll keep it like this. 1.96 is equal to negative 2 divided by sigma M. Normally sigma is a standard deviation that has to be a positive value. That's why I made this as a negative value. So we are considering this negative 1.96. So if I cross multiply, that is 2 divided by 1.96. See? So 2 divided by 1.96 is equal to 1.02040. This is the answer. So I'm considering only two decimal places in this case. So sigma M is equal to 1.02. Now we're going to use the equation for sigma M. Sigma M is equal to sigma divided by square root of n. Now we can substitute same thing as before. Now our sigma M has changed. Sigma was 20 divided by square root of n. So this is the value which we don't know. So I'm going to cross multiply, and n is equal to 20 divided by 1.02. 20 divided by 1.02 is equal to 19.607. This answer is 19.6078. So we can still use two decimal places. Let's go and see previous case. It was 20 divided by 204. This time is 1. So our answer has increased to 19.6078. Square root of n is approximately equal to 19.61, let's say. So I'm gonna get the squared value of both sides. So then my n is equal to 19.61 squared. That is equal to 384.5521. Since it's a sample size, so we have to use the next whole value, which is 385. This time the sample size is big. You can see we made a small change to the sample mean, but it affected the maximum sample size for this sample to be significant in this case. So the final answer is 385. And yeah, solve for this one.